Hello everyone, my name is Senior Suraj, computer science student at Makerere University. And in this video, I'm going to be talking about machine learning. To begin with, uh, machine learning, machine learning is a field that gives computers the ability to learn without explicitly being programmed. For them to use simply by matching patterns such that they can learn from the data. Um, let's talk about the types of machine learning. Types of machine learning, we have supervised machine learning and unsupervised machine learning. And in these categories, we also get other categories, that is classification and regression in supervised learning. And then in unsupervised learning, we have clustering. Before we go any further, let's first talk about training and the data set. So a data set is something that is humanly trained that doesn't have now, let's say the data that is being collected, let's say from the hospital, for the patients, and then the data that is got from students, any other data, population, can be climate, weather. So that data includes features. Features are the ones uh, that represent certain variables. Then we have the label. Label is the one uh, it's like our target. And then this data has instances. So wherever there is, let's say 1, 2, 3, those are what we call the instances. So to continue with training, training is like the learning process. This one involves like solving questions, comparing with like this example, solving questions, comparing with the answers, and then assessing yourself. And then you repeat the process until you understand. So that's how machines also go through as they are learning. So let's talk about making predictions. So let's say you want, after learning, you have to see whether you have passed or you have failed. So depending on, as I said, we are going to use a data set. So a data set, let's take it as an example as your practice questions. Now the training algorithm is the one that involves solving the question and comparing the answers. Now prediction is when you pass, let's say like you have solved the exam. Um, let's go back to our categories of machine learning. Supervised machine learning. So in supervised machine learning here, uh, humans are going to provide the computer with the labeled data so that it learns from it using the algorithm they made, be it Python or another language. So, as far as the machine learning, you label the data. Let's say you have images, you label them, cat, dog, um, and then after you give them to the machine so that it can learn from the data. So in this data, in supervised machine learning, we have regression and classification. Here, in regression here, we are going to use variables. Let's say we are going to use numerals. Let's say data that is in tabular form. So you provide the data with uh, inputs, let's say, uh, give them the dependent and then the independent variables so that uh, the goal here is to predict the value of the inputs you have provided to the machine or your computer. So the dependents are the one that you are predicting. Let's say you want to predict the price of a house. You have to first give in the what? The uh, um, so the independent features for them, they are the ones that predict the target. The ones that, let's say, in the house, there are rooms. So those rooms are the ones that are going to do what? Are going to determine the dependent variables. So types of regression, we have linear and logistic, and this precision trees and many others. So to talk about classification, for them here, we are going to provide the computer with images, let's say images. So it's going to learn from this data by recognizing the, those those images or the classes that are provided. This can be through, for example, you can say using the vector machines. So let's look at unsupervised machine learning. In unsupervised machine learning here, when we provide the computer with unlabeled data, so it uses the features of the represented information, studies it, and then uses the algorithm such that it learns from the data. So in machine learning, in unsupervised machine learning, there is clustering. Clustering is like grouping the other features that exhibit the same characteristics. Let's take an example of when you are running. When you are running, you can provide images when you are running, when you are walking, when you are rolling, and then the machine will be able to learn from them. So here, let's take an example of different users, Netflix users that have similar preferences. And clustering, we have hierarchical clustering. Here, you group data. Let's say you group it in different groups such that the machine learns from it. So anomaly detection here is like unusual instances or occurrences in the data set. Let's take an example when you're using a bank and then there is some amount usually withdraw from your account. So the machine will keep on recording that data. But when you do an abnormal withdraw from the line or from the bank, so the machine will detect unusual or an increase. So that means the machine, that is how I can explain anomaly detection. So models are representation of a phenomenon. And models, you have math models. So these ones include variables. So in math models, you have deterministic and probabilistic. Deterministic, here there is randomness in the data and the variables, and in probabilistic there is some uncertainty since it is probability. And in probabilistic models, there is regression models, correlation models, and other models. So in regression models, and the relationship between one dependent variable and explanatory variable. So here, these explanatory variables are the categorical independent. And these models are used for prediction and estimation. Let's continue with another topic here of machine learning pipelines. So here, when you're going to do machine learning, there's something you have to follow. So you have to get the data, perform exploratory data analysis, prepare the data for machine learning, select a model, train it, present your solution, launch, monitor. Okay, it's like the process you go through. So talk about the EDA. So here you are putting the data, so you are going to work upon it. You have to first explore it, and then you unravel the mysteries. So here you are going to do data cleaning and feature engineering. So this can be like you are going through the data to see which fields and which variables are there. So the EDA checklist here, you can see the number of observations, the number of features, the data types, the type of the problems you can solve, so even the outliers. So outliers, these ones are features that can be engineered, or you can add them, remove them, or edit. So when you get the data, you have to do other steps. You can do a qualitative field that can be using pandas, the libraries. You can do feature data types that can be numerical, categorical. I can plot distributions using histogram. You can also plot using the box plot and also study other correlations or do statistics, mainly statistics on the data. Talk about feature scaling. In feature scaling, it's like it's like you normalize and standardize the data. As you see here, uh, as you see here, let's say you have this actual data. So when you normalize the data, you are going to get the range of the data between 0 and 1. So you're going to minimize this data into 0 and 1 so that it can be easier to what to interpret. When you do standardization for it, you are going to transform the data to a mean 0 and standard deviation 1. So it's like you're going to center the data within here. So yeah, data after standardization will look like that. So let me talk about the training algorithm. So the key in your network, so it's like the steps. Let's say you have the data. There are some steps you follow when you want to do some statistics about it using KNN. So KNN, for it, you calculate the distances between the training data and the data set. Let's say you have this data distribution like this. So you're going to get the testing point or the new data point, and then you are going to find the k-nearby bars by sorting them in pair distances. So after doing this, getting the point or the new point, so you are going to get like 3 or 4, and then you see the distribution of that data. So KNN can be used in text mining, agriculture, finance, and cross validation as when the data set is randomly being split in 2 K groups, like as I showed you here. One group is used to test and the rest are used as the training sets. So let's say you have used this one, you can also make another group using this one, like that, like that, like that. So when we talk about the Manhattan and the Euclidean distance in KNN, so Euclidean distance like used in if the dimensions measuring similar properties like width, height, and length. Let's say you're having a point here and a point there. So it will be the Euclidean distance will be like that from point A to point B. But the Manhattan distance for it can be used for dissimilar properties. Let's say weight, age, gender, those ones. Now talk about feature engineering. Feature engineering is how you can choose the best features from the data set. Here and first study about the data as I told you before, and then doing here you can add in, combine, remove. And that brings me to the end of my presentation. Thank you for listening.